I just wanted to quickly go through biochemistry's 20 amino acids. So, tips and tricks. I started off by just memorizing the first letter of every amino acid, going from nonpolar to acidic. And the reason that I did that was the one-letter abbreviations for each amino acid can be confusing. So we have nonpolars, we have polars, we have basic, and we have acidic. And with nonpolar, I will show you why I write it out the way that I do. So you have GAVaLIMP, PTT, STAGC, and then LAHAG. It's not pretty, but it works. So we have glycine, alanine, valine, leucine, isoleucine, methionine, proline, phenylalanine, tryptophan, tyrosine, serine, threonine, asparagine, glutamine, cysteine, lysine, arginine, histidine, aspartate, and glutamate. And these first few amino acids are nonpolar. So glycine here through tryptophan are nonpolar. Also hydrophobic, right? Then we have our polar groups, which run from tyrosine to cysteine. And polar is also known as hydrophilic. And then we have our 3 basic amino acids and then our 2 acidic amino acids. So GAVaLIMP, PTT, STAGC, LAHAG. That was the easiest way for me to remember these and also to be able to group them into nonpolar, polar, basic, and acidic. You also need to know that phenylalanine, tryptophan, and tyrosine are aromatic. And it is obvious once you memorize the structures of these. So I'm going to start out with the nonpolar amino acids, and we're going to start with glycine first. So glycine, G, and every single amino acid has the same backbone. And that's the backbone there. So that is glycine, 2 hydrogens. Then we move on to alanine, ALA, A. Alanine, same backbone, and a methyl group on the bottom. Valine is next, Val, V. Oh, and up here I wrote valine as VA just because I didn't like the sound of GAVaLIMP, so I wrote GAVaLIMP. Just personal preference there. It's up to you what you would like to do. H3N plus here, hydrogen. We have that carbon. We add 2 more methyl groups on the end. And valine here makes an upside down V. If you're drawing skeleton structures, you can go from here. That's your H3N. This is your CO minus, and then you make another V. And these 3 down here are all carbons. So that makes your V there. However, I recommend drawing it as a Fisher projection until you know them like the back of your hand. Next we have leucine. So you have CO minus, you have your H3N group, you have your carbon here, and you have another carbon, another carbon, another carbon. So carbon is always going to have 4 bonds, no more. And right now we are in leucine and we have an upside down L. Next is isoleucine, ILE or I. And same backbone. I'm probably going to start getting a little lazy with the backbone, but I will do my best not to. So we have our carbon here, we have another carbon here, we have a carbon here, and we have a carbon here. And then you have an H3, H2, H. And this isoleucine makes half an I. So there's half your I. Next one is methionine. Methionine is met, and it's an M. So methionine looks like this. And methionine is going to have a sulfur group in it. So you're going to have CH2, CH2, sulfur, CH3. Okay? And that's your sulfur group. Some people like to make these guys kind of into an S shape so that they remember that methionine has a sulfur in it. But honestly, I just memorized that methionine is the way that it is. Next, we're going to go with proline. So you've got proline, P. And proline is another odd amino acid. And I'm going to draw this one a little bit differently. So this is an H3N+. Okay? We're going to draw a little house here. And this is the only amino acid that looks like this and doesn't have a legitimate looking side chain that doesn't connect to the amine group. So we have an H3N+ here. However, nitrogen can have more than 4 bonds. And when nitrogen has 4 bonds, it's a positive. So what we're going to do is we're going to get rid of that, and we're just going to put 2 hydrogens on there. So that's going to be an H2N. Okay? It's still going to be a plus, though. So that's proline. From there, we're going to go to phenylalanine. So phenylalanine and tryptophan are both nonpolar, but they're both aromatic. So I'm going to draw phenylalanine here. So, and phenylalanine is exactly what you think it is. They named it exactly what it is. So you have an alanine, and then you have a phenyl. Oops, I'm off the page. And there's your phenyl group. So phenyl, and then up here is alanine. Yeah? Okay. Next we have tryptophan. So tryptophan is the one that no one likes, and it's really not that bad. So we're going to have a CH2 here. We're going to have 2 ring structures down here. And it's going to be one that you just have to practice until you know it just like the back of your hand. So there's a nitrogen here, and there is a double bond here. And the nitrogen and the double bond are both opposite on the opposite side from this phenyl group. Now with tryptophan, the 3-letter abbreviation is trip, because it's going to trip you up. And the 1 letter is a W. Go figure, right? And one thing that's really going to help here is tryptophan makes an upside down W, if you will. So that could be helpful to you. So now we're going to move on to our next aromatic amino acid, and that's tyrosine. So tyrosine is tyre and Y, and we're going to have our backbone. And you are going to get really tired of drawing the backbone. However, that is one thing that you will never forget from biochemistry. So there's tyrosine. Tyrosine has this OH group on the bottom of it. So from tyrosine, we're going to move over to our polars. Tyrosine is considered polar. I misspoke, I'm sorry. So tyrosine is polar, but we're going to move on from our PTT, right? So we had PTT, and now we have STAGC. So we're going to move on to the rest of our polar amino acids is what I meant. So serine S, COO minus, H3N plus, hydrogen. And we're going to have one CH2 and one hydroxy group. So there's an OH there. Next is threonine. Threonine and T. And this one's going to have the same backbone. And it's going to be a little wonky though. This is a little different than what I would expect. But serine, when you add a methyl group to it, you get threonine. So that's why I write it in this order. Next we have asparagine, which is ASN and N, and we have our backbone, and we have our hydrogen here, and then we have something a little bit different. That is asparagine. It's a precursor to aspartate. So then we have glutamine, and asparagine ending in N and glutamine ending in N. That's how I remember the one letter for asparagine. And glutamine is a Q because they ran out of N's, I guess. So from here, same backbone, hydrogen, going to have a CH2, we're going to have another CH2 in line, then we're going to have a carbon, double bond oxygen, bond NH2. So from serine to threonine, we added another methyl group, and from asparagine to glutamine, we added another ethyl group. Okay? Next is cysteine. So cysteine, I've always remembered cysteine by saying schistine. So the reason I say schistine is because it has a sulfur group with a hydrogen attached. So I say schistine, and it has stuck forever. Next, we move into our basic amino acids. So our basic amino acids are going to be on this side, and it's L, A, and H, right? Because there's 3 basic amino acids. And over here on this side, we're going to have our 2 acidic amino acids, which are A and G, because it's LAHAG, or LAHAG, right? So lysine is a little tricky. The basic amino acids, in my opinion, are the most difficult to draw. So lysine has 4, let me draw this a little differently. It has 4 of these CH2 groups. So and then on the end it has that H3N plus group. And the reason that I can remember lysine is because it's LYS, and when you lyse something, you're killing something. So the one letter is a K. Now in lysine, when you draw a K, we're only going to draw part of the K, and we're going to draw it twice because we like K so much. So that's one little trick to remember lysine. You're killing something and you want to kill it twice. It's like the movie Zombieland. Anyway. Double tap, right? Anybody? Hopefully someone followed me on that. So now we have arginine, and arginine is a headache. So arginine, one letter is R. R, I can't draw this, is essentially where I was at for a long time. And arginine is tricky just because there are so many things going on. And from here, you go into a nitrogen, and then you have another carbon, and then you have more nitrogens. So when you think about arginine, you know it's a basic amino acid, so it's going to be having a lot of positives here. And it is just one that you have to draw multiple times in order to remember it. Next is histidine. Histidine H, and histidine's not so bad. You have your alanine, and then you have your little histidine group down here. So you got your two nitrogens here, and you're going to have a couple double bonds in here. That's going to be an H, and that's going to be an H. Now keep in mind that with amino acids, there are a few amino acids that have ionizable side chains. Lysine, cysteine, arginine, histidine, aspartate, and glutamate. The last 5 amino acids that we're going through all have ionizable side chains. And by ionizable side chains, I mean these positive groups down here. So those can change when you are working with titration curves, and I will do that in the next video. So the last 2 that we have are acidic amino acids, and we have aspartate, and it's a D. Since we're towards the end, we have run out of meaningful letters to use, so now we're just grasping at straws. And they pulled out a D, so there we go. Aspartate's D. And now glutamate. I remember glutamate because glue and the one letter is E. So I guess that's a little better. It's not great, and I highly doubt it was intentional. And with glutamate, it's just one more ethyl group compared to aspartate. So from aspartate to glutamate, you're adding one more ethyl group. And that's kind of how I've memorized the amino acids. If you guys have any suggestions or you really like the video, comment, like, subscribe, and good luck.